Okay, hello students. Here we are going to start the second experiment, that is resistivity of the material of the wire. Okay, in the previous class we have studied about resistance per unit length of the wire. Like we have got one wire of unknown resistance. That resistance we have found out with the help of Ohm's law setup circuit. Now let us find it out, the resistivity of the same wire with the meter bridge setup. Okay. So here what is the aim of the given experiment is, like we need to find out first the resistance of the wire, the given wire, and once we get the resistance of the wire, then we need to calculate the resistivity. We know what do you mean by resistance and resistivity. I will tell you once again now. Before going to that, let me tell you the aim, as I said you already, to find the resistance and to find out the resistivity of the wire. Then apparatus, what all things we require: meter bridge, experimental wire, plug key, resistance box, jockey, galvanometer and battery. Okay. Then principle. Principle is, Wheatstone bridge is a balanced when current through galvanometer is 0, and if PQRS represents the resistance of 4 ohms of Wheatstone bridge, then P by Q equal to R by S and current through galvanometer is 0. This is the balancing condition of the meter bridge. And formula to be used: resistance of the wire R equal to SL divided by 100 minus L. S is the standard resistance, small l is the balancing length. Once we find it out, the resistance R, then we have to proceed with the resistivity of the material of the wire, rho equal to pi r square capital R by L, and where capital L is the length of the experimental wire given. Okay. So these all things what I have written. Now I am going to explain you. Listen this. So as I said you, like we will be provided with the wire, its resistance and resistivity we need to find it out. Okay, resistance we need to find it out with the help of meter bridge setup. Once we get the resistance from the meter bridge setup, then we need to take the average of R, then we have to put that R value in this row. Okay. Now how to find out that resistance R? Look here students, this meter bridge is a setup which works on Wheatstone bridge. Okay. So what is that Wheatstone bridge? In the Wheatstone bridge we have, like in the theory we have studied, the circuit looks like this. Like we have 4 arms of the resistors P, Q, R, S. These are the 4 arms we can say of this Wheatstone bridge, 1 arm, 2 arm, 3rd, 4th. Okay. So these are the 4 arms of the given circuit, in which P, Q, R, S, see the cyclic order P, Q, R, S, these values represents the resistance of the 4 arms. Okay. So whenever the P by Q is equal to R by S ratio, at that time it will have the same potential point. So because of that, the current through galvanometer will be 0. Whenever P by Q is equal to R by S, current through galvanometer is going to be 0. So this is what the balancing condition. Okay. So this circuit, like our meter bridge, works on this principle. How it is? See, the formula which we are going to use in the resistivity setup is R equal to SL divided by 100 minus L. We know that resistance is directly proportional to the length of the wire. So in that sense, I can modify this formula with like I can write this formula in terms of this. Look at here, we have R equal to SL divided by 100 minus L. So P by Q equal to R by S. What are the 4 arms from this formula? Look at here, I can rewrite it as R by S. Take this S here, it is equal to what? L divided by 100 minus L. So this is what the 4 arms of the resistors of the given circuit, like R, S, L and 100 minus L. So these are the resistors, or we can say 4 arms of the Wheatstone bridge. Okay. So whenever P by Q is equal to R by S, the current through galvanometer is going to be 0, because it will have same potential on both the side. Because of that, if both the sides same potential is there, the current will not flow through the galvanometer. So current is going to be 0 across galvanometer whenever P by Q is equal to R by S. Okay. So this is what the balancing condition. And how we are utilizing in our experiment, like whenever I am moving the jockey on the this meter bridge setup, when I am getting, like on the galvanometer, when I am getting 0 deflection, up to what length from initial to final, that length will decide the balancing length. Means after the balancing length, the value in the galvanometer is going to be 0. So that length you need to find it out. You have to write it down, that is L value. by removing certain resistance from the box and moving the pointer or jockey on the meter bridge, you will be getting balancing length L. Okay, what is that balancing length? It is the length of the meter bridge at which the galvanometer is showing the zero deflection. Okay, so this is all about the resistivity of the material of the wire. Now we will proceed with the procedure, and followed by that we will be having a demo of the experiment. Okay, so main important in Viva, what they will ask what do you mean by resistance? What is resistance? It is opposition to the flow of current. Its SI unit is ohms. What do you mean by resistivity? Resistivity is the property of the material. Okay, it's the property of material. Same material will have the same resistivity. Okay, different materials will have different resistivities. Okay, so resistivity is the property of the material which opposes the flow of current, or we can say resistivity is nothing but specific resistance. Okay, with all the values of unit dimensions, I can say resistivity is same as resistance. Okay, resistivity SI unit is what? Ohm into meter. Okay, students, so write down these all things. In Viva they will ask you like the principle is P by Q equal to R by S, no? So from this formula they will ask you what are the 4 arms. So from that you have to get R by S equal to L divided by 100 minus L. So these are your 4 arms of the resistor. Okay, so hope you have understood this. And let us proceed with the procedure and demo. Okay, students. See the procedure. See, procedure is quite simple. Just to note down these things what I have written here. I will explain what all things we have to do. Here students, basically you will be provided with the unknown wire, means a wire with unknown resistance. I will show you the meter bridge setup. Just focus on the circuit diagram. Like with the once we made all those connections, we have to remove some keys from the standard resistance box. I will show you that. Once we remove some standard resistance from the box, that is what S value once we have to remove, like L and 100 minus L we have to measure on the meter bridge. Okay, the experiment here is from the meter bridge setup. First we need to calculate the value of unknown resistance of the given wire. The wire's length is 1 meter they have given, radius is 0.23 millimeter. That radius we have calculated from spirometer, from like spirometer or screw gauge. We have calculated previous year. In the first view we have calculated the radius of the wire using screw gauge. Okay, we have done that experiment. So we are taking directly that value 0.23 millimeter, the radius of the wire, and the length of that measured wire will be 1 meter. Okay, those things are given. I will write you there. So procedure is, once the circuit connection is made, just see your circuit diagram in the manual book. Again I will draw once again. We need to remove some resistance from the box. Okay, and move the jockey on the balance on the wire such that the point where the galvanometer is showing the 0 value, that L value you have to note down, and the remaining 100 minus L you have to note down. Complete is 100 centimeter wire. When you are moving jockey on the balancing length wire, L you have to measure at what length the galvanometer is showing the 0 value. That length you have to calculate, and the 100 minus L also you have to note down for the 3 different values of the resistance which you are removing from the resistance box. Note down L and 100 minus L. Calculate resistance R. Once we calculate resistance R, we need to calculate the resistivity of the given wire with the formula area into R divided by L. Pi r square into R by L. Okay, once I will go with the setup, I will explain you all. Just observe this. Okay, students, look at here now. I have drawn the circuit diagram. See, this is the circuit diagram for this experiment. See, this setup is called what? This you can see. This is actually a wire on the wooden stick. This setup we are calling it as what? Meter bridge setup. Here we have a resistance of a wire whose resistance is unknown, that we are pointing it as what? R. Then S is what? A variable. This is a resistance box indication. The arrow indicates what? It is an example of what? Variable resistance. Okay. S is the resistance which you are removing from the resistance box. Okay, and G indicates galvanometer. This is a battery, this is plug key, this is one wire. Now I will show you on the setup. This is jockey, this pointer indicates what? A jockey. The observations are radius of the experimental wire and the radius of the experimental wire will be provided to you. Radius will be 0.23 millimeter, length of the given wire is 1 meter. Okay, and this is the tabular column. Trial number 1, 3 trials you have to do. Actually, in our experiments, graphical experiments you have to take 6 readings, non-graphical experiments 3 readings are enough. Okay. So, trial number 1, 2, 3, resistance S in ohms, balancing length L in centimeter, 100 minus L in centimeter, resistance which you have to calculate by the formula SL divided by 100 minus L in ohms. So, calculate the 3 trials and write all the calculations like this. Trial number 1, R1 means this resistance from the first reading, R1 is SL by 100 minus L, similarly R2, R3, take the average, add and divided by 3. And once we get R value here, once we get R value, we will get some answer here, and calculate the resistivity rho equal to pi R square R by L. This small r is 0.23 mm and capital L is this 1 meter, and this R value is this calculated value. Okay. So, circuit diagram is simple. These blocks will indicate the meter bridge setup. These are the 4 arms of the Wheatstone bridge. See here, students. It is what a circuit diagram for the given experiment. Here you have to understand the 4 arms. What are those 4 arms? Just now I explained, no, P by Q equal to R by S. Where are those P by Q and R by S? Look at here. Here we have R and S. So, remaining P and Q. So, we know that resistance is directly proportional to the length, right? Resistance is rho L by A. Resistance is rho L by A. Resistance is directly proportional to length. So, resistance values, since it is proportional to the balancing length, we are taking the balancing lengths as the other arms of the Wheatstone bridge. Look at here. L will be one arm and 100 minus L will be the other arm. So, R, S, T, Q. So, P by Q should equal to what? R by S. So, here we got that value. Look at this. R by S is equal to L divided by 100 minus L. Observe this, students. Here we have formula R equal to SL divided by 100 minus L. This is in the form of what? Actually, the balancing length equation. What is that balancing length equation? We have balancing length equation P by Q is equal to what? R by S. Here in this formula we have what we have there? R is equal to what? SL divided by 100 minus L. I will take this S here. What will happen? R by S is equal to, if I take S, remaining is what? L divided by 100 minus L. Okay. So, R by S is equal to what? L by 100 minus L. L by 100 minus L nothing but what? P by Q. So, this is what the arms of the given Wheatstone bridge. Once R by S is equal to L by 100 minus L, in the galvanometer the deflection is going to be 0. So, whenever you are moving this pointer on the wire, once you are moving this by removing some resistance from the box, once you move this jockey on the wire, at one point you will be getting galvanometer which is showing the 0 values. Okay. At what point, at what length from the beginning to here, when the galvanometer is showing 0 now, this balancing length you have to calculate. Okay. If it is some values, this balancing length is nothing but what? L, and remaining is what? 100 minus L, because complete given wire on the meter bridge is 100 centimeter, that is 1 meter wire. So, you have to subtract the remaining 100 minus L as the other arm of the Wheatstone bridge. So, this is the condition P by Q equal to R by S, which is nothing but from the formula L divided by 100 minus L. Okay, now let us proceed with the demo of the experiment. Once everything is written on the ruled paper where you have written procedure, below that at the end last the result with the proper SI unit. Okay. Now, let us go with the demo of the experiment. Okay. Hello students, just now I explained you the circuit diagram. Now I am going I want to show you all the experiment devices. See here, this is galvanometer. Here you are going to see this is symmetric. On both the side we can have the deflections 0 to 30 and 0 to 30 on either side. This is the galvanometer where you are going to check when galvanometer is going to show the 0 deflection values. This is jockey. This pointer you have to move it here, okay, such that when galvanometer is showing 0 deflection, that length you have to calculate. So this is a pointer or jockey which you have to move on the meter bridge. This is meter bridge setup. This is meter bridge setup. These are your two ends, these are your other two ends. Okay, this is will be your A and C point, this is your B point, this is your one of the arm where this is the wire of unknown resistance where you are going to connect here. Its resistance we don't know. From this setup we are going to calculate the resistance value. This unknown resistor, this wire of unknown resistance will be connected here. Simply we have to lose this and tie the wire and tight it. Okay. Then we know this yesterday, this is the analog key or one way switch or plug key. Okay. This is the resistance box. Okay. Here some values have been written. You can see this 1, 2, 3 values. These are all what resistance values. Which key you are removing, that key will be activated. It means that resistance you are going to use. Okay. If I am removing 1 ohm, it means you are using 1 ohms. If I am removing 2 more ohms, it means 1 plus 2, it is 3 ohms resistance you are calculating. Okay. So this is a resistor only, variable resistor. An example of variable resistor, this is called standard resistance box, which in the diagram I have shown you S. In the circuit diagram S is there, no? This is what standard resistance box resistance S, and this is R, means its resistance R to be calculated. Okay. This is your plug key, and these are your connecting wires. Okay. Normally we will take copper wires. Then this is what your battery eliminator. So here yesterday I explained, usually we take 4 volts for our lab. So this is battery eliminator. Okay students, now let us start the demo of this experiment. So this is meter bridge setup. Here we have 100 centimeter wire. This is actually made up of manganese wire, and here these are your arms. This is first arm of the meter bridge, this is the second arm, and remaining L and 100 minus L will be the other two arms. So basically this meter bridge works on the principle of Wheatstone bridge. So let us start the connections now. Look at here, point A and point C. Point A is connected to the positive terminal of the battery. Let us connect that. Point A is connected to the, let us assume this is the point A and connect it to the positive terminal of the battery. Just connections are simple, just lose it, wind the wire and tight it. Then from the negative terminal of the battery, connect it to the plug key. So from the negative terminal of the battery, connect it to the one side of the one way plug key or switch, and from the other side of the plug key or switch, it is connected to the C part. So this is our A part, this is our C part. Now take one more lengthier wire and connect it over here. So from the plug key, connect to the point C. Okay, so this much part we have done now. So coming to here, look at this point B. Point B is this point. So this point is connected to the one end of the galvanometer. So this is the galvanometer. Here we have both sides symmetric readings. So let us connect this black end, that is negative end of this galvanometer. Let us connect this to the B part. Okay students, we have done this part. Now this other end of the galvanometer is connected to the jockey. I have taken already one lengthier wire. Just lose it, wind the wire and fix it. So this is called what, a jockey or a pointer, which you are going to move on a wire. Connect this to the red end, means positive end of this galvanometer. Any one connection we can use. So both sides we have seen symmetric. Any negative or positive terminal we can use. Okay, right now I have connected jockey to the positive terminal of the galvanometer. So now this much part is over. Now coming to the other two arms. So this arm I am going to connect the resistance, standard resistance box. So here just lose this screw and tight this. So in between that you have to fix the wire and connect this to one arm, one end of this arm. Okay, and the other side, this side, connect it over here. Okay, look at the students, we have connected, yes, this is a standard resistance box. This is an example of variable resistor because different keys are there. So different resistance we can remove from the box and that we can use it. Okay, now coming to this other arm. This is one more arm of metal bridge. Here I am going to connect a wire of unknown resistance. Its resistance I don't know. It's simply a conducting wire whose resistance I am going to calculate with the help of metal bridge. So let us connect this thing, one of the arm. We know already Wheatstone principle, P by Q equal to R by S. If that condition is going to satisfy, we can calculate with the help of that equation the resistance of this wire. Okay student, now everything is completed. We have connected this resistance of unknown wire of unknown resistance here, and plug key over here, and the galvanometer negative connection here, and jockey to the positive end of the galvanometer. So circuit is completed according to this. Now write down this observation, radius of the experimental wire. This radius we have calculated from screw gauge last year first few experiment. Take these two things are given, it will be given in a question paper. Radius of this wire, unknown wire, resistance of unknown wire 0.23 millimeter, and length of the experimental wire is 1 meter. So write down these two observations. So these are given things. Now let us start the experiment. S resistance S in ohms means from this box you need to remove some resistance which will be called as S value. So I am going to remove 1 ohm. So remove 1 ohm, look at here. So here 1 value has been written. So if I remove first key, it means I am using 1 ohm resistance. Okay, now I am 1 ohm key is removed. It means 1 ohm we are using in a circuit. Okay, so S value is how much now? 1 ohms. Now we have to calculate the balancing length. Balancing length means the length of the meter bridge at which galvanometer shows zero deflection is called balancing length. Now by removing 1 ohm, keep the battery at 4 ohm. Now plug in this, everything is ready. Now start from the origin, from the center. Like once we start from this side, I have removed 1 ohm key. Now before starting this, make sure that you have to check whether your galvanometer is right or not. Means we have to check either side opposite deflection, because at one side we are going to get zero deflection. So let us check that symmetry. If I keep here, I should get deflection on this side. If I put this pointer or jockey here, I should get deflection this side. Okay, this shows what opposite deflection. By putting this jockey here, I got deflection opposite side. By putting this jockey here, I got opposite deflection. Okay, somewhere in between I am getting zero deflection. That length I need to calculate. So let us start from this side. So I need to move this jockey on a wire such that I should get the balancing length. See here values have been written. It is 100 centimeter scale, meter scale. At what length you are going to get zero value, that you need to check it. Okay, so you need to find it out. So move this slowly until you get to zero deflection. Okay, now I have got zero deflection. Look at this value. Okay, at around, okay, it is just minutely, it is fluctuating. So I am going to take 44 centimeter. At 44 centimeter, I am going to get a zero deflection. At 44 centimeter, I am going to get zero deflection. So note down this 44 centimeter as balancing length. So remaining 100 minus L, you need to write it. Okay. Then remove one more key. Remove 2 ohms. Now 1 ohm keep as it is. Remove 2 ohms. So I have removed 2 ohms. Check opposite deflection. Okay. Now start from this side. Again you need to calculate the balancing length. The length at which galvanometer shows zero deflection. Now the length you can see here, it is some 37 point something, so it is 37.2. Now by removing 2 ohms from the box, I got 37.2 centimeter. Now I am going to remove 3 ohms. So by removing 1 and 2, 1 plus 2, it is 3 ohms. 1 plus 2, 3 ohms. Now again find out the balancing length. At some length you are going to get zero value. So here I am getting at I have got this zero value at 31 centimeter. Look at this. So here I am getting zero deflection. Okay, at what length I got? This is at exactly 31. So I am going to write, by removing 3 ohms, I got the balancing length as 31 centimeter. Okay, by removing these certain resistances, we have got the different balancing lengths and we have calculated the R value, the unknown resistance of the given wire, and average value I got 1.101 ohms. Okay, you have to show trial numbers like this, students, in the in the journal. You need to write on the blank page white sheet. You have to show separate trials like this. Find out 3 R's and take an average of that, and this is your final R resistance, and calculate the resistivity. Resistivity is pi R square R divided by L. Small r is this much. Radius of this wire is 0.23 mm. R 1.101 and given length of this wire is 1 meter. Okay, so once we calculate this, we are going to get 0.183 micro, that is 10 to the power minus 6. So I have written resistivity rho is 0.183 micro ohm into meter. So this is what your resistivity. Students, whenever you are working on meter bridge experiment, in order to get the accuracy, take the readings in between 30 centimeter to 70 centimeter. So as it is there in the precaution table, you can see this value of balancing length should be between 30 centimeter and 70 centimeter for accuracy in all Wheatstone bridge related experiment. Jockey has to be moved gently over the meter bridge wire. Okay, that's what I said now. Readings from 30 to 70, if you are getting as a balancing length, that will be more accurate. So hence we are going to conclude this experiment. So we have successfully calculated the resistance of this wire and we have calculated its resistivity. Okay, resistivity unit is ohm into meter. Okay, now this is what the end of this experiment. Thank you.